Turner here with Quadratic Formula Day 2. Our learning target for today is I can use the quadratic formula to solve any quadratic equation. Okay, add SQ6, quadratic formula, Day 2, setting up and solving. Make sure you have watched SQ5 before tackling this new steps. SQ5 dealt with just step 5, and we're going to add on steps 1 through 4 today. So step 1, if necessary, add or subtract terms so that the quadratic equation is set equal to 0. Identify your A, B, and C. Write the quadratic equation template under your problem. What this means is you are going to fill out the quadratic equation, putting in parentheses every time you see a variable so that you can go back in and plug in those values. That's what you do in step 4. And step 5 we talked about yesterday, which is do the math. The acronym Be Smart helps you remember the order of operations. So let's get right into it. In our first example A here, we have all of our terms on the left, which means I can jump right in and identify A as 5, the coefficient of x squared, B as 9, the coefficient of x, and our constant is 3. Now the quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So it's much easier when you have the template already for you. Now you're going to do the math like we did yesterday, but instead of writing out every single step, we're going to square and multiply in the same one. So you have negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times 5 is negative 20, times 3 is negative 60, all over 2 times 5, which is 10. Now, I have negative 9 plus or minus the square root of 81 take away 60, which is 21, all over 10. You get to leave the answer just like that because they wanted our answer in exact form, and the square root of 21 cannot be simplified. The square root of 21 is in simplest form. 3 and 7 are the factors, and they are not perfect squares. So we get to leave the answer. This is our answer right here. It's ugly, but it's accurate. Going on to example B. Once again, for example B, we have all of our terms on the left. Our coefficients are negative 3, 2, and our constant is 7. So we have negative 3, positive 2, and 7. Filling in our quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now I'm going to evaluate. X equals negative 2 plus or minus the square root. 2 times 2 is 4. Negative 4 times negative 3 is 12. Times 7 is 84. All over 2 times negative 3, which is negative 6. I have negative 2 plus or minus the square root of 88 all over negative 6. Now, unlike example A, the square root of 88 is not in simplest form because 4 times 22 are factors of 88. So I can break this square root apart and get 2 root 22. So I need to replace square root of 88 with 2 root 22. And once I do that, I notice that there are greatest common factors, 2, 2, and negative 6, and we need to reduce that. We're going to factor out a negative 2. Now, the cool thing is with this plus minus, we no longer have to worry about the sign there because it's going to be both of them. And now this -2 and this -6 can reduce to 1 over 3. So -2 becomes the 1. -6 is 3 because we're going to reduce by the 2. And our final answer is 1 plus or minus the square root of 22 over 3. Take a moment. Think about how are you feeling with this topic? This is our second day of it. Hopefully it is becoming a little bit more familiar, but as always, go back and rewatch parts that you're unsure of, talk to a classmate, or ask someone for help. Either way, now is a great time to do some math.